Okay, so gonna work on parting off the elevator halves and getting those all finished up. So the same process as the wing in order to define that sort of parallel to the flight path line. I pick a couple points on each stab half here and just ran my ruler across. So I know now if I make a perpendicular line from that, that will be parallel to the center line of the fuselage. The points I picked really are just the extension of this back cutout here, the cutout on the stabilizer side, and the intersection of the tip, because that's where I'm going to cut to anyway. So I'm just going to mark off a couple of 90-degree lines to that with my square, and that will establish our cut lines. Stab's a little bit simpler because you don't have to deal with the root. You're really just cutting the tip off the root. We're going to figure out that angle after the fact. So there's those two lines. So there's both my lines for flight there. And then just like the wing, I use my little spacer tool and I'm just gonna extend these over there. So really those are the two cutoff points. Okay, so now that we got our rudder hinged and we confirmed that that angle works out good, we go ahead and mark that off. So I really just use my template to establish, just on the hinge line, and then just so it all matches up, right? Trailing edge, hinge line, root, everything matches up nice, and then I'm just gonna mark that off both sides, and then I'm gonna add 1/8 of an inch to that mark. While I'm marking both of those off, I've also drawn on my template the servo box for the elevator servo. I'm gonna mount elevator servos in the tail. If you're not gonna do that, obviously you don't need to bother. I size this for a BLS 173, so it's the mini servo, 1/8 of an inch capping all the way around the perimeter of that servo. So I'm gonna just mark the corners of those with a pin, and then I can use those marks to draw the line for the box. Okay, I got all the marks in here now for trimming up the end points and whatnot. I did have to adjust the drawing there that I had on my template for the elevator servo just to make it parallel or in the direction of flight. Again, I just use that with the same sort of ruler and square trick that I did for all the other things where I'm trying to square it up to the direction of flight. So I'm going to go ahead and cut these out on a scroll saw. This is my 1/8 inch line. I just used a piece of 1/8 inch balsa to mark that off. This one here, so this line here, I actually went 1/8 inch inside the 1/8 inch capping that's already there, just so when I finish it up there'll be an 1/8 inch space between the fuselage and where the elevator is. So it just gives me my bit of offset on the elevator. Make sure you're doing this the right way around. So this is my left and this is my right stab. So if you used, if this is sitting up and this is your right and this is your left, obviously you're going to put the servo holes on top. So don't do that. We'll do these with a Dremel after I get all the rest of the parts, the elevator cut off. Okay, I got all the elevators cut out, ready to go for capping. So I'm going to go ahead and cap those the same way I've done the ailerons and the rudder and all the other parts. Just get those finished up, and then I'll show you what they look like, how sort of the orientation I did them in before I go ahead and finish trimming them up and then beveling them and whatnot. Okay, so there's all the capping taped on. Hard to see in here, but I've got the angled piece there, the end cap there, the leading edge and the tip, both sides done like that. And then the stab, same basic technique. I've not done the servo boxes yet. If you're really prepared, you could have this cut out and did them all at the same time, but I'm going to get the capping finished up and rough shaped out, and then come back and do those servo bays. So we'll let this set up, and then I'll go clean it up off camera, show you what it looks like after I've rough sanded it out, and then we'll work on the servo boxes for the stabs. So here's our stab halves after I've got the capping rough sanded down. I didn't walk through that part because you've seen it before. I taped them in place just so they're not flopping around here. You see the gap turned out real nice. You know, there's our root capping. So you see how I overlapped this piece on that piece. So you can kind of see the joint right there. You know, we ended up with our recess in there, about 1/8 of an inch off the fuse. So it all turned out pretty good. So I just threw it on here just to double check how our templated guide worked to get that relief cut in the elevator half. So that worked out pretty good. And there's basically our rudder deflection. So pretty much spot on the money. Now obviously I'm not going to run that much deflection except for stall turns. And I will have a bit of that foam in the fuse, so really in reality this is probably going to stick out more like that. So when we get up to full deflection, you know, we're going to have a nice little gap in there. Okay, so now that we're happy with all that, what we're going to do next is I'm going to cut out the holes for the servos and put those bits of wood in for the boxing, and then while that's setting up and drying, I'm going to do the beveling and hinging on the elevator halves. Exact same process as doing the wings, so I won't show it. But again, the same sort of thing, draw a center line, mark your angles. In this case, I'm going to do 20 degrees deflection, so 10 degrees on each half, on each part, the stab and the elevator. Again, make sure you get a left and a right, and your servos are underneath the model and not on top. Okay, so to do the servo cutouts, what I'm going to do is I'm going to score out where I'm going to make the cut. I'm going to score that out with my knife and just pick that balsa out of there. The reason why I do that is once the balsa's out of there, it's just the foam, and the foam is super easy to router out. Okay, there's our foam for the hole for the servo. Okay, so I'm just going to use one of these. I'm going to put some tape on this. So my tape. So the reason why I put tape on the bit is I can go right up against the edge of the wood and use it as a bit of a guide to router around that hole. So that way I don't have to, you know, worry about cutting into that wood. I just run the tape on the edge. So there's the servo box hole. You know, it's fairly tidy. And if you want to do a bit more cleanup on that, you can. It's not, like I say, no one's really going to see it once your servo's in there. So yeah, let's do a test fit. Now I'm going to use 1/8 of an inch, so 1/4 inch total. So I'm going to take 1/4 inch and the servo, you know, and it goes in there nice and snug. And then on the length, you know, got to get the servo wire out of the way here. On the length, same sort of thing. It's going to go in there fairly snug. So, you know, if you do want to make a bit of adjustment to that, now's the time. Okay, so cut my parts out. I cut out 2 sets. These are the long way and these are the short way. We're using a BLS 173 Futaba servo. Easily probably one of the best servos for this application. Elevator, you know, servos back in the elevator halves, or even probably ailerons on the biplanes. But yeah, great little servo. So these are they're not a 20 by 40 millimeter servo. They're 15 millimeters wide, and I forget the exact length, but they're definitely shorter than 40. So test fit them. Again, always test fit. You can always fix stuff now. It's much more difficult to fix it later. Same sort of process. We're going to stick the 2 vertical sides in, and our narrow ones are going to go in like so, front to back. And if we just hide the lead up in there for now, we can test this out, and you betcha, there it goes. Nice fit, very snug. So the reason why I keep them so snug is that really you know, that servo can't move much in there. You know, it can't get pushed around by the surface or nothing. It's pretty much fixed in place. Now, if you think you might try different servos, you know, or you know, maybe you're trying, you know, a mid-sized servo like this one on the ailerons, and you want to swap it to a big one, you know, obviously you got to put the servo box in for the bigger servo. So that's the one downside of doing this method and being so tight, is that you really don't have a lot of extra space. So think about that a little bit ahead of time. I didn't mention it in the previous videos and thought I'd mention it now. So okay, so we got the beveling done on the stabs. Same technique as before. So again, 10 degrees each side, so about 20 degrees of total deflection. So you'll notice, again, I don't have the hinging in here yet, but you'll notice, you know, if we deflect that, we end up with a nice even gap there for the hinge line all the way along. So we're gonna go ahead and hinge this now. Also same technique, you know, I equally spaced all the hinges, 5 of them. I put the little marks, maybe a little bit difficult to see. You know, they're there, there's one there. So I got the hinging complete on this one. Here's what it looks like. Again, there's the gap when we got it closed and open. It's about 20 degrees of throw. You know, just double check that, you know, your hinge is fairly centered on there. And again, if you want to tidy it up, you know, put it in the shucks, right? And go ahead and, you know, use that, sort of set the level and sand that up nice, so you get a nice even transition from the surface to the elevator half. Okay, so roughed out the servo box, rough sanded it. So I need to find out where the hard point's going to be. So I'm going to do the same basic step as we did with the ailerons. So again, let's fit the servo in here. You know, now this, you know, we want this linkage to be perpendicular to this hinge line. So again, this is going to be kind of twisted off at a bit of an angle. It's not going to be straight perpendicular or parallel, I guess, to our servo box. So I've sort of approximated where that horn is going to be, and I did draw, you know, roughly, I guess I'll use an ink pen here, roughly where that, you know, where those arms are going to go. Now I normally use a 6-point arm, and usually the outermost arm for the elevator throw. So I'll measure basically off to that, which is right, you know, I'll just kind of mark roughly where that is, right about there. And we can be a little bit inside that. So again, we'll use our squares. Our little trick, we'll find the hinge line. Slide these up and just mark off where that line is. So just to make that a little more accurate, I'm going to stretch that line out further, so then I can use the whole, you know, base of the triangle to sort of line up on that point. So that's essentially going to be a center line of our push rod right there. So it does just so happen that that's going to intersect our hinge. I kind of failed to see how much angle that's going to come back to. So we will have to move this hinge a little bit, probably inboard, maybe even make it a bit narrower to fit in that spot, but not the end of the world, no big deal. So now that we got that marked, need to figure out sort of how far back the center of that hard point has to be. So again, we're going to take our horn assembly and just sort of figure out, and it's about 7 millimeters is where. So from the center line of that hinge back to the center where we're going to put that bolt through is going to be 7 millimeters. And so that'll give us the correct offset spacing. So if we draw a line back 7 millimeters, so there's our center of our, that's going to be the center of our hard point right there. So in this case, because the hinge gap's not nearly as wide, that's going to basically set that hard point pretty much right where we wanted it when we did the rudder. So we're not going to have to, you know, offset that bolt at all and have it kind of out of position. It'll be, if we drill that exactly on center there, we'll be pretty much right on the money. We can just drill in the center of the hard point. So I'm going to go ahead and drill both those elevators up. I'm going to drill them up with the elevator and the stab attached to the shucks, just to give it the most support. I find if you just do the elevator, you know, it without the hinging in it and sort of by itself, you know, it easily deflects the foam when you do that. But when you have it all joined together, it's definitely a better supported drill, so your drill gets a little more straight. So I'm going to go ahead and drill that up and show you what these look like when they're done. Okay, so there's our elevator half with the hole in it. So pretty even, and just, you know, just on the edge of where we beveled it. So kind of how we want it. So there's our dowel fit in there. And so the reason why I don't put another block in there, some people might put balsa blocks inside there, is really this dowel is glued to the bevel. So it's pretty, you know, it's pretty robust in there. It can't really go anywhere. So, and it did manage to intersect our hinge point. So part of what I'll do is I'm just going to put that hinge just on the inside. I might cut it in half and just do sort of half a hinge here, just to support it a little bit better. So I'm going to mark these off for both elevator halves and polyurethane them in there. And then when that's all cured up, we'll do the final drill for the control horn, and that'll be a wrap on the elevator halves. Okay, so finished up drilling the hard points and putting in the horns. Same process as on the rudder, so I didn't show it. There's the top countersunk in, and there's the bottom. Again, you know, that washer's pretty tight to the leading edge. Now that does, you know, stick out 7mm, so it's basically right over the center of the hinge line once you get that top horn piece on. So what we're going to do now is drill out for the servo lead. So I've kind of marked off location at the back. I'm going to put the servos in, you know, this orientation. So I just marked off location at the back. That's going to intersect the edge of the servo box. I'm just going to use my sharpened brass tube here to drill out those holes all the way through into the servo box. So there it is. There's the servo lead hole drilled out with servo basically in place. I'll probably end up having it up higher like that, just so it, you know, or maybe even slightly angled, just so there's, you know, get a bit of a straight shot to that horn, which we'll do later when we put all the rails and whatnot in. So that's good for that side. Go ahead and do the other side, and then work on the retention bolt for the tube. Okay, so got this set up with a tube in here. Now we need a retention screw on each side. You know, you can clamp it with the adjusters, but I find it's just a tighter fit to the fuse if you use a retention screw on each side. So I've got that stab pushed all the way in, and I'm just going to really locate the hard points for those. I'm not actually going to drill the holes all out and put screws in them, just mainly because I want to get it, you know, with my foam and everything in there, and do it on the plane after it's fitted up. So really right now is just to get the hard points in. So to get the center line of that stab, I really just eyeball it. I don't try to get it too perfect. I just kind of line up about in the middle of the stab, you know, where try to get it parallel and roughly in the middle, and that'll be pretty close. As long as you hit the tube, that's really all that matters. And really just draw a line on there. Now, if you remember, there was a hard point at about 100mm out, so I'm not going to go all the way to 100, I'm going to go to 90. Just to be inside that. I just don't want to accidentally drill into that thing and when I'm doing it later and have to drive a screw through that hard point. So I'm just inside those. This is sitting at 90. So what I use for hard point is just a little piece of end grain balsa dowel. So it's just like that. Just a balsa dowel, and I'm just going to basically router a hole in there and just polyurethane that dowel in place, And it's really just to give you enough support on your screw so that you don't crush the surface. So just go ahead and use your circle maker. Find one that's about the right size. It's not super critical exactly where you locate these. So I'm just going to go ahead and use my Dremel tool, and I'm going to groove that down right till I'm touching the socket on the tube. So that way it glues to the socket, it glues. I'm not sticking it into foam, I got a good penetration into everything. So there's the first hole done. You can see the black of the socket in there. So I'm really just gonna, put my dowel down there, measured off the length. I'm gonna cut that off and then just polyurethane that in there and just put some tape over it, and we'll sand it off flush later. So there's the finished stabs. Sanded off that little hard point there. So we go ahead and drill them out later. I mean, if you want to drill them out now on one side of the tube, that's fine too. I'm going to do it after the fact. So everything's done. Ready for the servo, rails. We've got our hinging in, horn and hard point. So really all that's left to do in these is final shape, the leading edge and tip, and all the final sanding for covering. So weight wise, with the horns, and these are about 2 grams each. So this was 100 grams, and this one's 97. So without the horns, basically 98 and 95. So 3 grams difference. So pretty close again in weight. All stock stuff from the kit, nothing replaced or not used. And just scrap 1/8 inch balsa from my pile. So again, it's sort of the weights you can expect to get out of the kit.